Welcome back. So, last time we were working on the flood fill, the algorithm for our metaball collection, based off of the Bayer matrix. Allows us to blend multiple colors together. One thing I didn't mention, it's like in the render ordered dither circle, that only manages two colors, like primary, secondary color that blend between each other. But obviously this one has like a whole range of colors, from bright green down to dark green. I want to review that for just a minute. The thing that makes that work is this: instead of just choosing the secondary color, we're linearly interpolating between the primary and secondary based off of the intensity. You know, I don't remember why I'm multiplying that by 0.5. Why was I doing that? Oh, because if you don't do that, then you just get these hard cutoffs between the two colors. If that's something you want, then you can do that. I like the dithering effect, so I am going to keep that in place. But there you go. Let's see, taking a brief detour from the path I was on. We're going to actually look at carving. I've been working with metaballs. If you turn that algorithm inside out, basically, so that instead of rendering circles into a sample field, you're starting with a full sample field that you're carving into directly, you end up with something like this. Wait a second. Where you can actually draw the field. I cannot remember. I thought I had this colored a little differently before. Let's see if we can debug this for a minute. Let's see. Cleaned up the bootstrapping process. Everything related to setting up the dependency injection and console arguments is all stuffed into the bootstrap class, wires everything up for us. All we need to pass in are the app settings class and the main state class. So that makes it a little bit easier to swap out the pieces. We have a new map carving state. And some of the concepts are similar to the video I posted previously on writing with fire. You have a carving brush that will write a circle into the sample map. And where was the rendering function? Render samples. Rendering the segments. Basically, we had the segment rendering in the blob collection, and it is still there for now. Later on, we're going to shift this around a bit, but we're allowing the sample map to basically render itself. I have an outline color here. We don't have the fill color. Okay. And I want to be able to play more with this in the future. For example, it would be interesting. I've seen algorithms for rendering mazes based off of circles instead of squares, but I've never had a good way of representing the data structure before. But it would be really neat to have a random maze generator that could render circle-based maps. neat how you can kind of, it's like left click will carve into the map, right click will restore. So you can kind of see how it's an interesting way of drawing. It's almost like it really does feel more like molding clay instead of drawing pixels. You really have to try to understand. I'm not really sure how to describe it with words. So this is only rendering with the outlines. And I'm going to go ahead and switch over. We're going to come back to this in a later video, I'm sure of it. I have a growing itch to get out some maze rendering algorithms that I'd worked with in the past, just to see how I can get them to work together. I think that'd be a lot of fun. Okay. Well, let's take a look at this. We're going to go switch to the very final branch. It's still a work in progress. I think it'll always be a work in progress of one kind or another. Oh, wait. Not ready for that one. Hold that thought. We have 3 states here. We were just on map carving. Let's load that one back up. Okay. Blank screen. What's going on here, if you look at the sample map class, render method, first we render the Bayer field based off the same algorithm I showed you earlier, and we're rendering an outline. So if we come here, left click is to draw, right click is to erase, and there you go. It really does. This is actually, like the way this feels a lot more. I've modified the brush so that it carves, rather than carving at a constant rate, it's based off of the elapsed time since the last frame. So if you are moving the mouse quickly, it won't carve as deep, or you just tap it. You can change the size of the brush. One of the things I really like about this algorithm, it really does feel like almost like you're carving into a big chunk of rock. Let's see, make this brush really big. Erase the whole thing. And it's kind of pretty easy to write with. So it's neat. It's based off of that same algorithm that's driving the metaballs themselves, so it's really easy to blend multiple shapes together. If you don't like the exact shape of one of your letters, you can just like fill it out a little bit like that. I don't know, it's interesting. So, I do want to come back to this later. I want to see if I can incorporate this concept into a game map of some kind. I do want to do something with mazes. Now, got one final thing to show you, and that is the blob critter state. We'll start with the demo. Now I have 2 metaball collections, and you can see they kind of follow the mouse around. I had to do a lot of math to make this work right. watch this. So we'll go back to, let's see, where's our states? Program, blob critter state, and you can see we have multiple critters. We'll get back to how they're being done soon. If we go into our render method, this is an interesting problem. I've been using parallel for loops wherever I can, just to make things run faster. If you render two critters at the same time, you get that. Because they're both fighting for who gets to use the pixels in their region. So that doesn't really work. That is one of the cases where you really have to do things one at a time. Don't want them racing to see who gets to touch the pixels first. I have the event handlers attached, so you can still like grab the pieces, move them around, and resize them. And you can delete balls, but you cannot add because it's like don't have a good way of defining. So which critter are you trying to add a ball to? Their speed is based off of how far are they from the mouse cursor. As they get closer, they slow down. Got a little bit of an inertia thing going on, causing them to overshoot at first. And each one, like for each critter, has a radius that all of its pieces need to stay within a certain size, just to keep the balls from flying off the screen. They're going to the balls in each metaball collection want to pull back to their origin. And alright, so we have a blob critter which inherits from the iEvent handler, just like the event metaball blob collection. And they are created based off of these create blob critter props. Defines there's a randomness involved in their creation. Like how many balls are they made up of? What is their speed? How much friction do they have with their environment when they're trying to move around? How far can they stretch? Let's see, how was that one used? Radius, that's the total radius of the bounding area. So the balls cannot go beyond the stretching scale. Think of it like stretching some goo. Like how stretchy is that goo? And then within the create blob critter props, we have let's create radial blob props. And that's getting sent into the blob factory itself. A radial blob is a blob that is going to be placed somewhere around an origin. Like based off of as a min radius and the max radius. What else was in there? Yeah, just that. And then if you pop into the factory method, it's going to pick a random angle, random direction around that point, and it's going to pick a random radius within a certain range for how big the blob should be, and it's going to place the blob at that point away from the origin. So it allows us to place little blobs in a rough circle. And then we have a collection of behaviors. If we go into the props again, we have one behavior here, mouse following blob critter behavior props. It's kind of a mouthful, but it's defining the speed with which a blob critter will notice that the mouse has moved and then begin accelerating towards the mouse cursor. And those... There, we have a behavior factory. we throw, like the behavior factory takes a base behavior props record, and then based off of what type of props it's taking in, it will construct the appropriate behavior. All that, ultimately, this would help. It makes it easier to serialize your blob critter if you can pull everything back to the props used to create the object. Let's see. The math here, there's a lot of math, and most of it has to do with making sure that blobs stay in a certain area, and that it has to manage both the springiness of the blob and the inertia, which is based off of the blob's size. And then we're doing a similar thing for the entire critter itself, the way that we're moving it around based off of its speed. Like, we've got two concepts. We have the velocity is more like the direction. The speed is absolute value, scalar value. And I would have liked for this to go into a behavior, this concept of like pulling all the bits back into the, basically pulling the center point of the blob back towards its center of mass, which would kind of, when a blob is accelerating across the screen, it causes it to kind of pull back when its components haven't caught up yet. Which is a bit easier to see if we turn on the debugging outlines, which have been moved into the debug flag. Set that to true. And it seems now it's going to render the grid. That plus sign is where the blob is located. The circle defines its bounds that it's going to try to keep all of its blobs inside of. The red circle, or not the red circle, the red plus sign there is the center of mass for that critter, which is, the center of mass is different from its position, and the center of mass is trying to get to the position. It's kind of fun watching them orbit. So it's not exactly the skeletal-based critter that I was talking about last time. It's the start on something, and it would be a neat way of rendering some kind of creature in a virtual world. I haven't quite figured out what that world will be yet, but it will have blob critters, and it will have mazes, and wonderful dithering effects. I want to modify the behavior collection. Like further development on this would include giving the blobs a sense of maybe their temperature, that they want to stay within an ideal temperature range and move towards someplace that's not too warm or cold. If you're going to give them a sense of how hungry they are, you create another behavior for that. Tells them like, you're getting hungry, go find some food. But then you would also want to change this list, like give each behavior priority. Like different behaviors have different priorities. Seeking after the mouse is relatively low priority compared with, like, are you hungry? Are you cold? Are you too hot? Are you feeling sick? And then you'd want each behavior to be able to calculate its own priority and then change its position in the list based off of that. If you are really hungry, if the blob is hungry, it's not going to bother following the mouse, it's going to go find something to eat, that kind of thing. So I think further development might include giving it some priorities like that, really basic intelligence, and possibly putting it in a maze or cavern of some kind with some temperature and maps and food sources. And I would also be interested, let's see, if we go back to the blob editor, the third state here, it would be really interesting to create a way of drawing some kind of creations using these blobs, and maybe you can have different colors. Like, suppose you want to make a blobby tree and you have one blob collection for the trunk that you can color brown, another set you can make green, and then you can serialize that data required to render your blobby tree and then load that as a sort of a prefab into whatever other environment you're creating. And that's another direction that would be kind of interesting to go in. So we have three directions there. We have world generation. We have basically like art serialization, and we have more behaviors on the critters. And I'm hoping to pursue all three of those paths at some point soon. The next video, I'm going to be focusing a little bit more on AI. I have some ideas there I've been wanting to play with for a while. So, hope you can join me for that. We'll be exploring some things that we can do with extremely small language models that run locally on basically a mid-range performance laptop, which is what I'm working on right now. And hope you can join me. So, see you later.